Welcome students. Let us see a very important question from the chapter Mathematical Induction. Here question is, prove by the principle of mathematical induction for all n belonging to set of natural number. Here statement is 1 cube plus 2 cube plus 3 cube up to n cube is equal to n into n plus 1 by 2 whole square. So here mathematical statement which is given here is this one. Okay. And we will do it in 3 steps. In step number 1, we will show that this statement is true for n is equal to 1. The second step, we will assume that this given statement is true for n is equal to r. And third and last step, we have to show that this given statement is true for n is equal to r plus 1. Okay, these are the 3 steps for doing this question. So let us see the solution here. Here given this is mathematical statement denoted by Pn. So this is here 1 cube plus 2 cube plus 3 cube up to n cube. This is equal to right hand side is n into n plus 1 by 2 whole square. Let us call it relation number 1. Okay. So this statement is given here and mathematical statement is denoted by Pn. So first step will show that P1 is true. Means we will have to put n is equal to 1 here. Okay. So now to show that P1 is true, and for getting P1 we put n is equal to 1 in relation number 1. So here total number of terms is n, but whenever we will put n is equal to 1, we have to take only first term here. So here we will get 1 cube, and right hand side in place of n you have to write 1 here. So this is 1 plus 1 divided by 2 whole square, or we will get 1 is equal to, this is 1 into 2 by 2 whole square. So 2 will be cancelled out here. So we are getting here 1 is equal to 1. So LHS is equal to RHS. Here LHS is equal to RHS. So it shows that P1 is true. Therefore P1 is true. Now second step, we will assume that this given statement is true for n is equal to r. So assuming that PR is true, that is we have to put n is equal to r, putting n is equal to r in relation number 1. So we'll be getting here 1 cube plus 2 cube plus 3 cube up to r cube. This is equal to r into r plus 1 by 2 whole square. This is relation number 2. Now third and last step, here we have to show that PR plus 1 is true. Means we will put here n is equal to r plus 1. So now we have to show that P r plus 1 is true. So for this we will put n is equal to r plus 1 in relation number 1, and we will get, so this will be PR plus 1. Okay, and we will get 1 cube plus 2 cube plus 3 cube up to r plus 1 whole cube. And here right hand side is, in place of n we have to write r plus 1. So this is r plus 1, and here r plus 1 and plus 1. So r plus 2 divided by 2. This is whole square. Correct? Now here we have to establish that LHS and RHS both are equal. So let us start with LHS. But in this left hand side, you see up to this much part, 1 cube to r cube, you see relation number 2. In place of this much statement, we can write r into r plus 1 by 2 whole square. Okay, 1 cube up to r cube is this much, 1 cube into r cube is this much. So LHS will be here r into r plus 1 by 2 whole square, and last term is here r plus 1 whole cube. Let us simplify it. We can take r plus 1 whole square common from both the terms. So here r plus 1 whole square is common. From here you will get r by 2 whole square, isn't it? So this is r square by 4. R square by 4. I hope you are following it. R plus 1 whole square is common, and r by 2 square is r square by 4, and plus here this is r plus 1, because r plus 1 whole square has been taken common, so remaining part is r plus 1. So this is r plus 1. We will simplify it further. So this is r plus 1 whole square, and this is r square plus 4r, taking LCM here, LCM is 4, 4r plus 4 divided by 4. Okay, now we are coming to the final step here. This is r plus 1 whole square, r plus 1 whole square, and this is r square plus 4r plus 4 is r plus 2 whole square, r plus 2 whole square, and denominator is 4. So this can be written as r plus 1 into r plus 2 divided by 2 whole square, and you see this is right hand side. So we have started with left hand side, we are coming to right hand side. So therefore here we are getting LHS is equal to RHS. So PR plus 1 is true, that is PR plus 1 is true. Now we have to write one line statement at the last of this solution. What we will write? We will write that by the principle of mathematical induction, this statement is true for all n. So therefore by the principle of mathematical induction, statement Pn, this given statement Pn is true for all n. So we got the result. This question has been proved here. So this is a very interesting solution. So in this type of question, we have to do always 3 steps. First step, we have to show that P1 is true. Second step, we will assume that PR is true. And third and last step, we will show that PR plus 1 is true. After that, we will write this one line statement, and this problem will be solved. So hope you have understood very well. So students, I hope that will keep viewing my videos so that you could understand this chapter very well. Chapter is very interesting and very important. So be in touch with us, and we will enjoy mathematics throughout. Thank you very much. Wish you all the best.